Hi everyone. So the first thing that we will do now is we will add physics to our game. Okay, so we will tell our game that the laws of motion will be followed in this game. Okay, so for that, Phaser provides you with physics engines, and the very first kind of physics engine is called the arcade physics engine. So we will configure that physics engine. Okay, so it will allow us to simulate basic laws of motion like transfer of momentum, adding gravity to our game, speeding up objects, giving them some velocity, and so on. Okay, so we will say, okay, the physics engine that we need to configure is called as arcade. Okay, and if you want to implement some rotational mechanics, okay, so laws of rotational motion, so then there are more complex physics engine that are available that you can use. But for the arcade physics engine we need to configure few values. Okay, so that will be applicable on our game world. Okay, so one value that is very important is the gravity value. Okay, so you can give gravity along any direction. Okay, so there can be you can have gravity along x-axis, you can have gravity along y-axis, you can have gravity along minus y-axis, and so on. But in my case I'm just going to have a gravity along y-axis. So I will say gravity along y direction will have a value 1000, and that's it. Okay, you can you feel free to experiment the values of gravity, but I have tried this value and it works perfectly fine. Okay, so more gravity means higher gravitational pull. So we have configured the physics engine. So this is what you need to do to add physics engine to your game. Okay, so create a physics object inside your config object, configure the values of gravity, and set the physics engine as arcade. Okay, so let's do the next step now. So what we will do is we will try to add a player in our game, and we will make sure that player follows the physics that we have. So for that, first we need to load the player image. So let me show you. So if you carefully see, okay, this is the image of the player that we have in this case, and it's basically called as a sprite map. So you have a lot of images, but we will pick only one frame out of this to display our player, but the other images are given to us so that we can create an animation. Okay, for example, if your player is moving towards right, you can actually play these images by looping them over so that it appears like the player is moving left. And similarly for the left direction, here we have the for the right direction, and this is the player when it is standing, it's not moving. Okay, so we have 0 1 2 3 4 5 6 7 8 9, we have 9 frames, and you can see. So what we will do, we will try to load this not as a single image, but we will say it's a different kind of image. So we have a different type of a function to load this particular sprite sheet. So let's go to game.js, and in the load function we will say this dot load dot sprite sheet. It's called as a sprite sheet. Again, you need to give some key. Let's say key is dude, and you need to give the image, so it's dude.png, and also you need to define two things. One is the frame width. Okay, what will be the width of each frame inside it? It's going to be 32. And frame height. So you can use any image editing software to calculate these, or you can just divide the available area in the number of frames you have. Okay, so let me show you here. This is dude.png. so you can see the height is almost 48 pixels, and each frame is going to be around 32 pixels. So if you have a total of somewhere around so total it would be, let me show you what would be the total. So total it would be we have 9 frames, 1 2 3 4 5 6 7 8 9. So it will be 9 into 32. it will be total of 288 pixels. You can verify. Okay, so it's almost 288 pixels by 48 pixels. Okay, so let's go to the game.js file. So what I have done is I have defined, okay, this is the area that each frame in this particular image will occupy. So this area is 32, this is 48, so that is one frame in which our cartoon or in which our character is there. Okay, so this is also 32 by 48. So this is the function that you will use to load this kind of a sprite sheet. And if you're interested, you can download sprite sheets from a website called Open Game Art. So you will find lot of characters here. Okay, so you can search for a player and you can get some of the sprite sheets. Okay, or you can say boy, so you can explore. Okay, or you can create your own artwork in Photoshop, or I picked this sprite sheet from the Phaser website from one of the examples, so I'm using it directly. Okay, and I think the sprite sheet size should be a multiple of 2 or something like that. Okay, it should be a power of 2. Sometimes all sizes do not work with the sprite sheet, so you have to be very careful. If you get an error with the sprite sheet, probably it's a problem with the size of the sprite sheet. Okay, so now let's see how we can create a player object using this sprite sheet. Okay, so let's go to the create function, and let me say we have let player equal to something, so it's going to be this dot. So one thing we can directly do is we can add it like a normal sprite. We can say this dot add dot sprite, and here we can give the key. Let's say at 100,100 we need to create the dude. Okay, and by default you can specify by default which frame will be shown. So the 4th frame will be shown. Okay, let me okay, we got some error here. Okay, dude.png is not there. Yes, so it's there in the assets folder. So we fixed the path and we load it. Oh, sorry, we should fix this thing. It's dude and the path is assets/dude.png. Invalid frame width, so this should be width and like this. So now you can see we have added the sprite sheet at this particular point. So this point is 100,100 here. Okay, but this we want this player to fall. So what we can do is, instead of adding this as a normal object, we can actually use our physics engine to create this sprite on the screen. Okay, so what we can do is, do not add it as a normal sprite, but add it as a sprite on which the physics is also applicable. So we will call the function called this dot physics dot add sprite. So now you can see it's falling from this height, and it's falling because of gravity. Okay, so if you want to add some physics to your sprites, so you will use the function this dot physics dot add sprite. Okay, and if you give a certain different frame, you can see the player is facing left, and if you give 5, you will see the 5th frame the player is facing right. So we keep it as 4 because it is facing front. Okay, so let me show you console.log player. So here you will see, okay, so this is your player object, and now this player also has a body. It has lot of properties. One of the properties called as bounce. We will see how to work with this bounce property as well. Okay, so let's see the next step. So what we want to do next is, instead of player falling through the ground, we want the player to land up on the ground. Okay, so what we will do, we will say, okay, the player and the ground will collide and the player will stop after colliding with the ground. So we will first convert ground sprite into a physical object. Okay, so we will say the physics will also act on the ground so that we can detect collisions, we can do transfer of momentum and so on. So let me say okay, so we will say this dot physics dot add existing. So if there is an existing sprite, for example, we have the ground sprite that is already existing, so we can add that to so that the physics also gets applied on the ground. So let me show you. So now you can see both ground and the player are falling, but this is something that we do not want. So what we will do, we will say ground dot body dot allow gravity equals false. So we do not want the gravity to act on the ground. Now you can see, if I just show you console.log ground, now this ground object also has a property called body. Okay, you can see it has a property called body, and we have allow gravity equals false. We can set this value to true also, and then the ground will start falling, you can see. Okay, so what we can actually do is, once we have done this, we can use the inbuilt collision detection mechanism and framework to detect collision between the player and the ground. Okay, so we will say this dot, okay, let's add a collision detection between player and the ground. Okay, so this dot physics dot add dot collider between the ground and the player. So now you can see what happens. So once the player lands on the ground, both start moving with the same velocity, because in our game we have not defined any mass for both of them, and what happens is, due to physics being applicable, the momentum of the player gets transferred to the ground. So what we need to do is, we need to set another property of the ground that is called as ground dot body dot immovable. That means the body cannot move in any case, so we have to set this property as true. So let me show you, and now you can see, once we set this property, the immovable property of the ground object, okay, and the player successfully lands on the ground. Okay, so you can see this is how we can do this. Otherwise there is an alternate option. So the alternate option is, when you are adding ground object here using this dot physics dot add, you can, by default, you can say this ground is a static body. Okay, so by default every body is a dynamic body, so you have to pass a parameter called true that makes this ground as a static body. Okay, and by default this parameter value is false, that means it's a dynamic body, and you can see the same thing will happen. So you can also do this thing. Okay, so that's all for this video, and I hope you got an idea how you can make a player land on a platform.